So this is Chapter 2, Section 2, Properties of Quadratic Functions in Standard Form. This is Lesson 2, Video 1 of 2 videos, and this one is about minimum and maximum. So minimum and maximum values are related to your vertex. The first thing that you want to understand is really what the basic is, and it's super simple. The lowest point would be your minimum, and then the highest point would be your maximum. So when looking at a vertex, if it's facing up, as it does in this first graph, it's going to have a minimum, while if it's facing down, like it is in the second one, it's going to have a maximum. The second part is domain and range. Well, if you remember back to when domain and range was originally discussed, domain is the left and right motion, while range is the up and down. So if you were considering a parabola, which is what a quadratic produces, you'll recognize that the arrows mean that this graph continuously goes down. As it's going down, it's going to get wider. And since it never stops getting never stops getting wider, your domain would be considered all reals, and it is all reals at all times for all quadratics. So all quadratics domain is all reals. Okay? Which is kind of nice. It makes it super easy when working with quadratics. Now, when it comes to the range, you have to consider the whole concept of boundaries. Is our graph bounded above or below? Well, if it's facing up, it's bounded below by the vertex. And if it's facing down, then it's bounded above, again, by the vertex. And since we're talking about the range, that's talking about your y values. So the k from your vertex would be what produces the correct range. Now, next phase, how do you write the little piece of the set notation? So if it's facing up, it's going to be greater than whatever the k value is, and if it's facing down, it's going to be less than whatever the k value is, so whatever the y value is in your vertex. This is a little strange at first, but the more times you do it, it'll become quite easy. It's just a matter of looking at the shape, finding your vertex, and then deciding if it needs to be less than or equal to or greater than or equal to. We will do more domain and ranges, obviously, through practice. So this example says, find the minimum or maximum of f of x is equal to 2 times x squared minus 2x plus 5, and then state the domain and range. The first thing that you want to do is to look at our a. A is equal to a positive 2. This means the graph is going to be facing up. Because it is facing up, we already know that we are going to be working with a minimum, not a maximum. From here, we need to actually find the vertex. When you find the vertex, x is going to be equal to negative b divided by 2a, because we're working with standard form. So a, b, c. So negative b over 2a is negative of a negative 2 divided by 2 times 2. So 2 divided by 4, which is 1/2. This is not the minimum, it's the x value. We need to look for the y value. So plug it in. 2 times 1/2 squared minus 2 times 1/2 plus 5. That's 2 times 1/4 minus 1 plus 5. That's 1/2 minus plus 4. So 4 and 1/2 is our y value. That means that our vertex is 1/2 comma 4.5. The y value is the minimum. The x value is what minimizes. In other words, produces the minimum. And the reason why that's the case is because it's the independent variable, while the y is the dependent. So without the x, you will never actually get the minimum or maximum. Again, the key is to start by finding your vertex. So once you found your vertex, the answer is the y. Okay, so that's step 2. So it's pretty straightforward when you're trying to find the minimum or maximum. The next step is the domain and range. When finding the domain and range, again, you need to remember that this is a quadratic, so your domain is all reals. So it shouldn't take you very long to write it out. This simple means x for every real. Now the range is related to your minimum or maximum. And this was a minimum, so it's a minimum of 4.5. Now, because it's a minimum and our graph is facing up, everything above it is what's going to get larger, which means that we need to say it's greater than or equal to 4.5. Again, you need to watch out for all the different steps and make sure that you are paying attention to the minor little pieces of your vertex and making sure that you plug in things correctly. For your utri, you're going to find the minimum or maximum and then state the domain or range for f of x is equal to x squared minus 6x plus 3 and g of x is equal to negative 2x squared minus 4. That is the end of this video.